Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, Computer Science and Information Technology. Here myself, Mallesham, Devasane. In this session, I'll be discussing the most and very important topic for the theory of computation, where to identify CFLs and DCFLs, we should be good at constructing PDA and DPDA. So most of the people that they have a problem in a construction of PDA, and so in this session, if you have any such problems in constructing PDA, so we can resolve that by understanding the approach to construct. Okay, let's begin. How do we construct a PDA or DPDA with the help of the knowledge of this tag? Okay, let me introduce myself if you are not aware of my details. My complete name is Mallesham Devasane. I'm verified educator on Unacademy. I work as an educator in the segment GATE and ESE in Computer Science and IT branch. And for accessing all my free classes, please use DEVALIVE as referral code. And this is my profile link, unacademy.com/DevaGateCSE, or you can search my name, you can see my profile anyhow. So if you want to know about me, I worked at various institutes for taking the GATE classes, and I completed my MTech from IIT Bombay before taking the GATE classes, and then almost I have guided more than 1 lakh students who are preparing for GATE. C programming, TOC compiler, these are the popular courses that you can find under my profile. DEVALIVE is the referral code. DEVALIVE is a referral code to get 10% discount on Plus or Iconic subscription, and also you can access my free classes on Unacademy. Okay, benefits of the Plus: you will have a live classes, crash courses, weekly tests, doubt solving, and English and Hindi language, as well as the rank improvement batches and many batches on Unacademy. So all of them you can access freely if you are Plus subscriber. Iconic, you will access or you will get all benefits of Plus. Additionally, personal coach and material, study planner and study booster, as well as test analysis. And these are my classes on Unacademy. You can access absolutely free, and just visit this profile and use referral code DEVALIVE to access all my free classes, also other classes from other educators too. And how do you visit Unacademy? So if you are using a laptop or PC, you can use www.unacademy.com and choose GATE and ESE. Before that, log in, and while logging, if you are asked with any referral code, you can use DEVALIVE as a referral code and enter it and search my profile, or you can go for subscription if you are interested. And these are the benefits of Plus and Iconic: best educators and interactive live class and structured courses and live test quizzes, and many benefits in the Plus, right? Even though we are all not listed, but everything which is there inside Unacademy is completely free. But if you want more than that, then you have additionally assigned with a coach and test analysis, study planner and study material that is going to be additional for Iconic people. So this is more beneficial than the Plus. And if you are looking for the Plus and Iconic subscription, what are the advantages? You will be learning from the top educators from India. Like, all these educators are well experienced, and you will get courses, you will get an access to every course from every educator, and many more educators are there on Unacademy. So all of them are absolutely free if you take Plus and Iconic subscription. And if you are interested for Plus, and these are the plans: 1.5 year, 2 years. This is the price for each plan. But use DEVALIVE referral code to see this price after the discount. And for Iconic, 1 and 2 year plans are very popular: 40,500, 54,000 respectively. But do not forget to use DEVALIVE. And you can access all our classes on this platform, on this YouTube channels, and please learn and keep interacting with us and keep liking our sessions. Yeah, good evening, Shubhasri. And do not forget to like our sessions, which is more important. Yeah, let's begin today's class. Okay. Fine. In the previous session, we have seen context-free grammar and also previously regular languages. And what is PDA? We have learned in the previous session. Okay, we can accept a context-free language with final state or with empty stack, with both mechanisms. That is going to be PDA. And DPDA I have given definition. You can use either final state mechanism or final state and empty stack together, but only empty stack we should not. So we will see after learning construction. So here today we are looking at construction of PDA. Okay, first problem, I have explained already how to construct a PDA. So initially I am using final state mechanism. And this is DCFL, so you can use either PDA or DPDA mechanism. You can use a PDA knowledge or DPDA, so I will help you both of them how to implement. Yeah, good evening of them. And I'm using dollar as end of the input. I'm using Z0 as initial top of the stack. If you don't assume, you can forcefully put a Z0 on the stack. Fine. Now, initial state. If you remember the previous one, you want mn equal to 1. Sorry, additional condition. M is equal to n. M equal to n. So, slight change to this one. Okay. Additionally, put m is equal to n. Okay. Push every A, push all A's, but how? It's just like every A push one A comma Z0 slash A Z0. What will happen? If Z0 is there, A's are coming on the tape, the first A is going to be kept on the stack. That's all happens. But second A is not going to push now. This transition will help you only for the first symbol. So second A, it is looking at top of the stack A. So A comma A. Now this will put A onto the stack. And third A, it can look at double A. So this can, the second transition can help you to push all the A's except the first A. Now these two transitions together will push all the A's. But this is a DPDA knowledge. You can also call PDA. But if you want PDA, which doesn't look like a DPDA, you can blindly do A comma epsilon by A. But this can't be used in DPDA mechanism. Remember that. This problem is DCFL, so I can design a DPDA which is already called as a PDA, and you can design even PDA which is not a DPDA. Remember that, because the PDA is more powerful than DPDA, so it can understand even DCFLs with some other way. Now both of them are same. Here is going to push all the A's, but without looking at the top of the stack. These two together will push all the A's, but by looking at top of the stack. Right, we have two motions here. Why I am talking about the two motions? Because people might think about DPDA not exist when they design PDA wrong. When you design a PDA, think about DPDA might exist sometimes. Okay. Now, when B comes, the top of the stack must be A, and we'll pop it. Every B we pop one A. And here also same mechanism. Without looking at the top of the stack, you can't pop. So here there is no problem. But if you want to see end of the input, you can. But end of the input occurs, then entire stack must be empty. So Z0 only left. Then keep Z0 and go to final. So whenever you halt at final, your input is over and also stack is empty. means only Z naught left now, and that represent A's and B's are equal. In case stack is not empty, then you will never go to final state. $Z naught to whatever, doesn't matter, and you will go to final. Yes, these both machines are accepting the same language, but the first one is DPDA, so PDA. Second one is a PDA, but this is not a DPDA. But still, there is a DPDA some other way. Remember that. How do you know it is not DPDA? Because the first transition, you are not taking the DPDA definition. Q cross sigma cross gamma. Sigma cross gamma. You are not looking at the gamma. You are looking at nothing. That is only can be done in non-determinism. Okay. This is the first problem, guys. Here, now, here m is equal, n is there, but m comma n greater than or equal 0. Now, what is the difference? It is the problem 1 union just epsilon extra. That means entire motion is same. Push the first A, push remaining all A's. When B comes, pop A. And after that, you can put self loop for every B, pop A, same job. But when end of the input happens, you go to final by looking at Z0 because nobody should left. Now at least 1A, 1B comes, you go to capital B, then go to final state capital C. But if you know input symbol is there, directly dollar comes from A and no A on the stack means Z0. Then this represent epsilon. This represent epsilon where n is equal 0. Remember that. That represent epsilon where directly dollar as an input and top of the stack is Z0. Go to final, but that happens from initial state. Without AB, you want to accept. So in the previous motion, just add one transition, which is $, Z0 from initial state. Now let's move on to the next problem. Third one, and m greater than n. I told you in the previous one, 4A, 1B. At least 1A, 1B should happen. More A's than B. What happens on the stack? Look at. Initially Z0. So this combination is A, Z0. What you want to do? Push. So we keep A onto the stack. And when you look at this combination, A, A, push. So another A happens here. Now same job, push. Same job, push. But when you see the B, A, we pop it. And when you look at the dollar, who is there on the top of the stack? A. $, A. It means A is more than B's. So we can accept. And what? Same approach again. Same approach. Entire process is same. Same again. A's, push. We don't know how many they come. Just push. Any number of A's, push. That is unbounded stack. Then when B's comes, but at least one B should come, but we don't know how many B's, but this B's must be less than A's. Then if it is less than A's, then when you see the dollar, definitely A's left on the stack. Do whatever, but go to final. This will represent, this combination represent when end of the input occurs. Dollar means when end of input occurs. A's left on the stack. It means A's more than B's. If B's are not able to pop A's, it means B's less than A's. B's are not able to pop all the A's because B's less than A's. When the dollar comes, A left on the stack. Okay, this is the third problem. Okay, now let's move on. Fourth one. Now, more B's. Now be careful. Dollar is at the end. And now we have initially just Z naught. A push, A push, B pop, B pop, B Z naught. Warning, don't go to final. Don't accept now. Why? Because input is not over. Why? Because input is not over. Input still left. Input is left with some symbol. So ensure. We know B's are more, but ensure only B's are there next. So what we do? Now onward skip. Skip means B comma Z naught, keep Z naught only. B comma Z naught, keep Z naught. And do the same thing for all B's. Then when dollar comes, now dollar comma Z naught, go to final. Now accept. Because here ensure only B's are there. If B's are not there, going to the final, when you see the extra B, then you are going to accept invalid string. Only B's are there, ensure that. But anyhow, these A's and B's are equal. Yeah, skip B's. Good job. So how do you do that? Any A's, push. It doesn't know that A's are less or more. It blindly push all A's. Every A push one A. And when B comes, we start popping A. We start popping A. But how long? If really B's are more, then B's will left on the input. That makes B comma Z naught condition happens. Now dollar comma A doesn't happen, B comma Z naught. When dollar comma A comes, we will go to dead state now because we don't want such strings now. B comma Z naught, keep Z naught means skip. And remaining all the B's skip. Now this will ensure more B's happened. But how long you skip the B's? Till the dollar. When the dollar comes, now you understood, okay, now my job is over, end of the input occurred, so now I will go to final. So this is how we design a machine. This is all machine so far except the first problem I have shown in the right side, all are DPDAs. All are DPDAs, guys. Okay. Fifth one. Now understand here, A power n, push, hash, skip. Here push A's I am doing. So when B's comes, pop A's. If really B power n, A power n, number of A's, number of B's equal here, then definitely when the dollar comes, stack left with only Z naught. So how do you do that? Z naught, and this A we push one by one, and hash just skip, and every B pop 1A. Every B pop 1A. Then when end of the input comes, only Z naught left on the stack. Yeah, stack empty means A's are completely deleted. Z naught is there, still stack is not empty. Okay, but logically you can assume it is empty. Okay, Q naught, the first A's only comes. If A's doesn't come, that is minimum string is hash. Remember that. Next to minimum is A hash B. So the special string we will take care of later. So first I assume that A's are keep on coming. Okay, when hash comes, who will be there on the stack? Two choices, either no A or A, both will be there, but both are different combinations. If A is there, keep A. If nobody is there, then Z0 will be there. Yeah, good evening Nishu. Clear this point? A because before hash at least one A might be there. Z0 because even no A also might be there. Two cases, but both combinations are different. That is why still deterministic only. But hash A you are writing 2 times, then that is not a determinism. That is non-determinism. Okay. Now we are going to skip only. Right? Hash we skip. But after that, if really A is left, then every B pop 1A. Then if no B comes, directly you will see end of the input. Either dollar or epsilon is fine. We'll go to final. Right, this is DPDA. This is DPDA. Yeah. So PDA, remember that. Okay. Sixth one. Okay, before going to the sixth one, if anybody interested taking Plus Iconic subscription, Plus or Iconic, structured courses, not from 1 or 2 educators. Remember, even though you use the code DEVALIVE, it's not just for my courses. It is for every course from every educator on Unacademy. This code can be used, and multiple courses for the same subject. And right, every course you have many educators and study as per your interest. You can join any batch, you can learn from anybody. That is the beauty of Plus and Iconic subscription. If you know about Netflix Prime videos, exactly same. Once you take the subscription, unlimited watch you have, and learn from top educators, study with proper planning, enjoy learning without losing confidence, and so far will find the best journey in your preparation. So that is the benefit of these subscriptions. Okay, next let's move to the sixth one. And A's. Now we have something like that. Let's say I have 3 A's. Then how many B's must be there? 3, 4, 5, 6. 3 A's means n is equal to 3. Then 2n means 6 A's. Now what is our job now? What is every A I can push even 2 A's if I want. Every A I can push 2 A's. Remember my logic. What I do, every A here, every A I can push 1A also. I am making one simple logic. Every A push 2A's. Then first A we push 2A's. Second A we push 2A's. Third A we push 2A's. Now begins B. Here every B pop 1A only now. Every B pop 1A. Don't pop 2A's. So what happens? This B we pop 1A, and this B pop 1A, and this B pop 1A, and we pop 1A, and this one, and every B we pop 1A. When dollar comes, we will go to final. We'll go to final. So if you understood, let's design the problem. And here epsilon doesn't happen, remember that, because that is the reason n greater than or equal 1 I have taken. Minimum string is A double B. Minimum string is A double B. This is the minimum. At least 1A, 1B guaranteed. So any number of A's. How to push 2 A's? Double A Z0. And if you have 1A on the stack, of course top of the stack, then above that you can push 2 A's. Then can I write that? Can I write that? Can I write that? You can see that. Q cross sigma cross gamma. Q cross gamma star. Yes, you can do that. Let's say this is a capital A state. From capital A, if you read A and Z0 is the top of the stack, I'm going to capital A. I can write any symbols here. I can write double A Z0. I can write 100 A's followed by Z0. Even I can push 100 A's at a time theoretically. Practically, it is your choice how do you push. Okay, now that will ensure that every A push 2 A's here. Now when B comes, we need to pop one A only because we balanced 3 A's, we made 6 A's. Now every B match 1 A. And every B pop 1 A. Keep on doing it. End of the input occurs sometime. At that time, only Z0 should be there because we want to see exactly B should be double to the A's. Then we will go to final. Right? This is B's twice to the A's. Number of B's twice to the A's. People can write some other way. A power M, B power N, such that N is equal to M, where M comma N greater than or equal to 1. This is another way to write. Fine. B's should be twice to the number of A's. Okay, seventh one now. This one I can write other way. A power M, B power N. Now M is equal to N. Of course, M comma N greater than or equal to 1. Now you take one string to understand. If number of A's must be even, remember that. If these are even, then B's must be half of that even. Then B's must be 2. Take the valid string to understand all the time. Don't ever take invalid because we are not showing any path to the invalid here. Okay. Now what is happening? Initially assume Z0 is there. Our assumption. A. All the A's push as it is, and every B you can pop 2 A's. You can pop 2 A's. Every B you can pop 2 A's. This is the one logic. What I did, every A push 1 A in the beginning, but every B pop 2 A's. This takes a non-deterministic knowledge, guys, because how can I do that? My definition is sigma cross gamma. I can't look at 2 symbols at a time. I can look at 1 symbol at a time only, but it want to pop 2 A's at a time. So using DPDA, that logic is difficult. So we have another logic too. We have another logic too. What is another logic? Every 2 A's push 1 A. Push 1 A. It means, how do you do that? First A skip, second A push. Or first A push, second A skip. But every 2 A's push 1 A. Every 2 A's push 1 A. And every B pop 1 A only. Every B pop 1 A. Every B pop 1 A. So now let's look at, here I can design DPDA easily. So we are going to think like a deterministic machine. Now, this is, you can design PDA. This you can do homework if you want it. You have a PDA for this. Okay, now let's look at this one. This is the logic 1. This is the logic 2. Logic 1 we are designing. Logic 1. How to design that? Same problem. We have, let's say, any number of A's. Oh, sorry. Now, logic is changed. I'm sorry. Logic is changed. Every 2 A's, what you have to guarantee? Push 1 A. So, first A, skip, and second A, push. There are 2 A's. Make a cycle. First A, push, second A, skip. Or first A, skip, second A, push. You have 2 ways. Anything is fine. And initially, A comma Z0. Okay. If I push, then A Z0. And second A, definitely you will not see Z0 anymore. A by A, keep A. And when you are getting third A, then definitely this is a different A comma A. Then push it. And this side is going to have the same transition. A comma A only. So skip one side. This is a push and skip. This cycle is going to guarantee every 2 A's we are going to push 1 A. Yes. Now from here only B should come. Remember. then B, every B pop 1A, because if there are 100 A's, then we have guaranteed only 50 A's there on the stack. That means that 50 A's on the stack must match with the 50 B's in the input. Then every B pop 1A, every B pop 1A. And when dollar comes, then stack must empty, means Z0 only should be there. Clear? This logic can be designed using DPDA, but second logic, you can't look at two symbols at a time using DPDA. That is the reason I didn't make it. Yeah. Fine. You can design a PDF for that, no doubt. 8th. Now special case, if you have any special case, yes, epsilon is not there, so no problem. Okay, next one. Very interesting problem. W, we never push W, remember that. We push symbols only. AAB, ash, BAA. If this is a W, then its reverse has to be W power R. It's a reverse. Reverse, remember that. So this B will match with this B, this A will match with this A, this A will match with this A. Then how do you implement stack? How do you implement a stack? Look at using stack. Initially Z0 is there. When you see first A, what do? Push. And A, push. B, push. We don't look at the combination, blindly we push. So doesn't matter what the combination is, we will push. But only ash comes, we skip and we start doing pop. But how? B comma B only. If B is coming, B only on the stack. If A is coming, A only on the stack. If A is input, A only on the stack. When dollar comes, we will see Z0 and we will accept. Final. Yes. Now, here two things. How do you push W? Push blindly. How long? Ash comes. If ash comes, skip, and W power R, pop, but by match only. Match with input and top of the stack. Okay, now let's look at. Here, anything may come, right? We don't know. A comma Z0 might be coming. B comma, first symbol may be B. First symbol may be B. And A comma A. A comma B. B. Just wait, guys. A comma Z0. B comma Z0 means nobody is. These are the first symbols. Already A was pushed. Now A might come. Already B was pushed, but now A might come. B is coming, already A might be there on the stack. B comma B. So anything comes, just push. Push. Already A is there, one more A, double A. Already B is there, A is coming. Already A is there, B is coming. B is there, B is coming. Now all of them are just push anything, push every symbol, every symbol. But how long? Till the ash comes. When the ash comes, you might see many things, guys. Before the ash, W minimum input, you see ash, guys, minimum input. That is a minimum input, because before ash nobody might come, because W can be epsilon. W can be epsilon or A or B, anything. If W is epsilon, then ash comes. Remember that. That means Z0 by Z0. If A was the top of the stack, A by A. If B was the top of the stack, B by B. That means whatever is there, keep it, because we are going to match now. How do you match? If A is in the W power R, top of the stack must be A, so pop it. If B is in W power R, then B must be in the W, pop it. If you do two things, then after some time stack will have left with only Z0. It should left with only Z0. When the dollar comes, only Z naught is left. It means go to final. So here this represent W power R, this represent W. So W hash W power R. It's a deterministic push down automata, guys. Yeah, deterministic push down automata. If you are watching this video, please don't forget to like the session, guys. Please like the session. Yeah. And now hash accepted. Yes, from initial state, by looking at hash Z naught, I can go to B and I can see the dollar next, because dollar is the end, but directly dollar will not come. Hash is the minimum input. Yeah. Clear? Yeah. Ninth one. Now here the input, there are two choices. There are two kinds of string, C double A double B. It's a one input, or it might happen D 4 A's 2 B's. It's your choice. But if C comes, you know what to do. If C comes, your logic is different. C comes, just skip. But remember what you are doing. Every A push 1A, every B pop 1A. So when dollar comes, Z naught. So logic here is to check equal. And here logic is, if D comes, you know what to do, skip only. But logic slightly changes. Now every 2A's push 1A, and every B pop 1A. Yeah, simply pop every B pop A, 1A only. So here you know that logic. Here D skip, and instead of 4 A's we push only 2 A's, and single B we pop 1A, single B we pop 1A. Right? So logic we are going to decide by looking at first symbol. Yeah. So first when C comes, go this side, but don't change the stack. If D comes, go this side. Already you know how to make DPDA, right? Already we have seen DPDA for this, like exactly the previous motion. Any A, push. If B comes, pop. But one equal we need to do. Equal. Now here dollar Z naught, go to final. And especially single C is also valid. So here directly dollar Z naught can come. Single C is valid. Single C. After C without AB also we can accept. Special case, that is. It's okay. Now another motion is, what you do now, every 2 A's we push 1A. So take the help of some dummy state. 1A go there and other A come back. But 1A push, other A skip. 1A push, other A skip. Now you decide how to design. Okay, 1A I push A Z naught by A Z naught, push first A, and then A comma A, because already A is pushed, skip, means keep A only, and when you are next time you are going to see the next 2 A's, then you will see top of the stack is A, then push, then other transition is same, because still it is A only. Now every 2 A's, now you will push 1A. Now after this, if B comes, pop 1A, then here instead of taking again, you can directly go to the existing one. I can go here, because now our job is same. Every B pop 1A, and if dollar comes, then go to final. But here single D is valid, so what you do, you can create dollar comma Z naught from here. You can write a Z naught or you can write epsilon, it is your choice. Fine. Dollar comma Z naught by Z naught or epsilon. You can pop Z naught or you can keep, we don't care. Yeah. Everybody? Yeah. There are many other logics to design a machine. Remember, I am doing only one way. right? There could be multiple logics to use the stack. Remember, infinite logics are there. Infinite logics are there to understand this problem. So you should be careful. In the exam, you should not assume your way they will design. You need to understand the way they have given to you. Remember the point. Okay, next. W power R. And this is one of the problem where there is no DPDA. If you try to think like a DPDA, never works. We have only PDA exist, and I can design, but understanding is not at all easy, and you should do a lot of hard work to understand this PDA. This problem is CFL, but called as but not DCFL. And how that is different? How that is different? Because right now you do not know when reverse of the string begins. That is the difficult. When will reverse begin? The W power R begins. Really you do not know. You do not know, because you have to scan from left to right, and you need to predict that using non-determinism. You need to predict that. But what kind of prediction? What kind of prediction? Look at that. Manually you know that here reverse begins, but there is nothing here. Nothing here. If you look at AA, reverse begins after 1A. If I give you 4A, reverse begins after 2A's. If I give you 6A's, reverse begins. But how can you do that? You don't know about the future. If you go last symbol, you can't come back. Then you need to start doing something. But when the reverse begins, these two symbols must be same. These two symbols must be same. So your prediction begins from the beginning. Your prediction begins from beginning. How? And reverse may happen here, may not happen here. Reverse may happen here, may not happen here. May happen here, may not happen here. May happen here, may not happen here. And may or may not. In these choices, and if you take choice, this A push, this A push, and here onwards, if you start popping, then you will succeed because it matches. But why this works? Because your string is finite length, so you will have finite choices. Among them, one of the choice definitely holds at final. So this is one of the problem you have not faced in the previous 9 problems at all, because previous 9 problems, they are deterministic languages, they are deterministic CFLs, so you did not face any problem. Now if you want to design a machine, look at this W. Any symbol comes, we push, but we really don't know how long. So I'm not saying Z not all these things. I'm simply saying A epsilon by A, B epsilon by B. This will ensure push everything you want it. Push A's and B's as long as we need, as long as we predict. If you don't want to push, no need. If you want to push only one symbol, you do that. If you want to push 2 symbols, you do that. You can do everything you want here, right? Because anyhow DPD is not there. Why do you want to look at Z naught is there or A is there, B is there? No need to do that. Blindly push. But if really my path goes to final, at some point of time I will change my mind. I don't look at my input, I don't look at the top of the stack, I don't do any operation, but I change a state. Here, if really the string is valid, somewhere reverse begins. When reverse begins, you do only pop. You do only pop. I predict reverse begins. This must be W power R. But only we don't know how long this W happens. It might happen, it might not. If it happens, definitely there is a path here. And when $Z0 comes, then go to final. Now, if you give me epsilon, do I have a path to final? Don't ask me why should I go that way, because that is a non-deterministic motion. I can take A and I can read epsilon and I can go to B, I can read dollar, I can go to C. But on this stack, I have a Z0 only. A is not looking at the stack. Blindly it is jumping to B, and from B I am looking at Z0, I am going to final. Epsilon accepted? Yes. S accepted. Now single A, not. Why? Because there is no path to the final. Now you might do something. Okay, A dollar. Suppose A on A. You pushed it. Without looking at, you pushed it. Now you went to A only. Now A. Now dollar I want. So I will go to B, let's say. Without looking, I can go to B. But B, if dollar is there, then A comma, dollar comma A, there is no transition here. Dollar comma A, no transition. So no path means dead state. It is going. It is invalid string. No path means invalid string. Invalid string, guys. So it's one of the difficult machine. Not only this, all the non-deterministic machines understanding is really difficult. So whoever designs that machine, you must carefully design and understand is that machine has at least one path for every valid string. That's all. But which path, you find out manually. You find out manually now. Okay, there are powerful machines to understand why this machine is accepting WW power R. Yes, but apart from this, you have so many other machines too. Like I can write very clearly, okay, A comma Z naught, A Z naught, A comma A double A, B comma Z naught, B Z naught, B comma B double B, A comma B, A B, B comma A, B A. I push anything I want, but when after some time I will change my mind. For some A, if top of the stack A, I may start popping, or if top of the stack is B, I may start popping. Here double A comma A, B comma B. Here non-determinism happens, guys. You can look at that. A comma A, we have a non-determinism. A comma A, B comma B, we have a non-determinism. Two paths are there. Two paths are there for A comma A. I may push or I may pop, and once I predict, only I start popping. And if you want to accept epsilon, we have other thing. What is other thing? Directly here, dollar comma Z naught you can take. Yes, this is another machine, but you tried like a deterministic machine, but you failed. But this is also PDA and this is also PDA. But in the second PDA, you are using like a DPDA machine, but you fail to design because same top of the stack, same input, same top of the stack, you have a true transition from capital A. Yeah. So this is pushed on Automata, but this is not a DPDA at all. Okay. Now in this session, we have understood construction of PDA, and we will, in the next class, we will understand how to identify CFLs and DCFLs, guys. Here, and we have designed very few, but we should be in a position to understand whether the given language is CFL or not, DCFL or not. So in the next session, we are going to discuss in detail how to identify. So these things will be given in the exam, so you will understand. But these things you will need to identify. They will give you language, whether it is regular or not, DCFL or not, CFL or not, finite language or not. You need to understand, you need to identify them. So for that, you should have good knowledge on the construction. Okay, in the next class, I'm going to do that. Okay, guys. So in plus Iconic, as I said, and anytime if you are interested to take the subscription, use DEVALIVE to take the plus or Iconic subscription, and you will not only get 10% discount, but also you will get a guidance to crack the GATE exam. So this is my profile. If you want to access all free classes from any educator, including mine, you can use this link to access my classes. You can use DEVALIVE to access any class on Unacademy, DEVALIVE. And you can subscribe to our Telegram channel, Unacademy GATE CS. We'll update daily our links and material. And also, you can share all our free YouTube channels with your friends, and this will help your friends, as well as this will help us to reach many students. Thank you so much, guys, and don't forget to like this session at the end. Please like this session and also share if possible and subscribe. Thank you so much. Bye bye. Take care.